Relationship between content provider and other components in Java remote method invocation. Here you can see architecture, basically stub and skeleton. The RMI system is designed to provide direct, simple foundation for distributed object-oriented computing. Architecture is designed to allow for future expansion of server and reference types so that RMI can add features in a coherent way. When a server is exported, its reference type is defined. In the examples here previously discussed, we exported the servers as unicast remote object servers, which are the point-to-point unreplicated servers. The reference for those objects are appropriate for this type of server. Different server types would have different reference semantics. For example, a multicast object would have reference semantics that allow for replicated service. With client, when client receive a reference to a server, RMI downloads the stubs that translate calls on a reference into remote calls to the server. As shown in this figure, the stub marshals the arguments to the method using object serialization, then send the marshaled invocation across the wire to the server. Server side, the call is received by the RMI system and connected to skeleton. Which is responsible for unmarshalling the argument and invoking server implementation of the method. When server implementation completes, either by returning a value or throwing an exception, the skeleton marshals the marshals the result and send the reply to the client stub. The stub unmarshals the reply and either returns the value or throws an exception as appropriate. Stubs and skeletons are generated from the server implementation, usually using the program RMIC. Stubs use references to talk to skeleton. This architecture allows the reference to define the behavior of communication. The references used for unicast remote object servers communicate with a single server object running on a particular host or pod. With stub reference separation, RMI will be able to add new reference type. A reference that dealt with replicated servers would multicast server requests to an appropriate set of replicants, gather in responses and return an appropriate result based on those multiple responses. Another reference type could activate the server if it was not already running in a virtual machine. The client would work transparently with any of these reference types. Here you can see, for example, exp server.getPolicy method as an example. Then in the stub, it's go through marshal parameters, send request, then it's moved to skeleton, unmarshal parameters, invoke implementation, it's moved to implementation, then return new today's policy for example, then it's moved back to skeleton and receive return O exception, Marshall return no exception, then send reply, then it's back to skeleton stub and unmarshal reply and return value throw exception. Now this is the end of my presentation. Thank you very much for watching it.